No, move over to 6 and divide by
Minus
8.
pencil.
Divided by 8. Because you have to get the thing alone.
I always leave mine at home somehow.
There you go. Okay, so today's assignment 1 through 14, looking at number 1. A couple of things to think about. Yes, you guys see the absolute value, and so parent function looks like this. We're not graphing these right now, but that's still a good thing to think about. Well, let's just start solving number 1, and when we hit the issues, then we'll see what happens. So what should we do first?
Minus 6.
Minus 6. So that was an easy call. And then divide by 8. Okay, now is where it's like, okay, here's the big deal.
7r minus 5 equals 5 and negative 5.
That's right. What's inside that absolute value bar, like ignore that 7r minus 5, what's inside that could be 5, but could be negative 5, right? Because the absolute value changes signs. So I'm going to say whatever's under my pin there has to be 5 or negative 5. So this always happens with absolute value. You're going to split it up into two pieces and say either what's inside there is equal to 5 or what's inside there is negative 5. How that relates to the graph, I mean, obviously that's not a graph of this particular one, but if you're wondering where the graph hits something, it could hit it twice. It could also hit it none, so that's when we have to be careful. 7r equals 10, r equals 10 sevenths. So we get a fraction, but it's the very last step, so that's not really a big deal. 7r equals 0. So what does r equal?
0.
Sometimes that throws people off. They get 7r equals 0 and they panic, rather than just divide by 7 and get 0. Um, 1 through 6, all about the same. What might we need to be worried about? If there's no solution, and what would make there be no solution?
If it equals a negative, it equals...
Good. If the absolute value equals a negative number, because you can't have that. And I was trying to look through these, like you don't really know that right away. You have to get it down to if you get absolute value equals negative, then there's no solution. I don't think that is gonna happen on number 2, isn't it?
That's going to equal negative 5. Right?
Yep. Absolute value of 7b plus 2 equals negative 5.
No solutions or no real solutions?
No solutions.
Or no fake solution.
I should put no solutions.
But you've got to be careful, because if you're not thinking, then you're going to set this one up just like you do all the other ones, and a lot of people will say 7b plus 2 equals 5, 7b plus 2 equals negative 5, and get a couple of answers, and neither of them are right, because this can't happen. So no solutions.
Will the final be on paper? Or
Paper. I mean, it's multiple. The final's multiple choice, and so it might be a Scantron.
Yeah.
But Ms. Houston and I talked about this yesterday. You will have a paper copy that you can write on.
Good.
So the whole final...
This multiple choice makes it so much better.
What geometry lectures
It makes it easier to grade, too.
Makes it much easier to grade. Makes it great for you, because then you can plug in. And on one like this, like if you saw no solutions as one of the answer choices, hopefully that'd be in your head. You'd be like, oh yeah, I need to make sure that, let me be careful. Whereas if you didn't have any answer choices, you might not even be thinking about it and miss it completely. All right, 3, 4, 5, 6 all look about the same to me. It's hard to tell, but I don't think there are any more no solutions. Like the number 6 looks fishy, but what happens with number 6? Divide by negative, so that one will be okay. So again, you can't make that no solution determination until you have the absolute value thing by itself. All right, number 7. It does equal 0.
So does it? No, because you're gonna like subtract it to.
Oh, yeah, that makes sense.
So
It's just one.
it's going to be one solution,
Yeah.
right? You can still think of it as set it equal to positive 0 and negative 0, but that's the same thing.
2 over 9. Did your teacher say?
And what that means graphically is that
It's like the vertex.
you're at the vertex. You're right there, so there's one solution.
That makes sense.
Let's skip down to number 7. Absolute value with less than and greater than.
Oh, were we using the number line position?
Yes, so graph on a number line.
Is it just the same process?
It's kind of the same process because you are going to split it into two statements,
Oh, you want like that?
Oh, it's the.
but it's the and and or stuff. And how do you remember which one goes with what?
Less than.
So there's that lesson in 2 lines. Less than, greater.
The only problem with this
And kind of like the last one, don't make that determination until you have the absolute value thing by itself. The only problem with this, Jack?
is we're doing all the stuff that we did at the beginning of the year now, which means by the time we get to the test, we'll have forgotten it.
We're reviewing too soon?
Yeah. Well, no,
Nah.
I think
You're good.
when you review, you should review backwards, I think. 'cause
Oh, I see.
beginning of the year, closest to the test.
Like a snake draft kind of situation.
Yeah, sure. Because otherwise, I'll
Let's do number 7. It's a fair point for sure. Let's see. 72 divided by 9 is 8. Okay, what's this sign mean?
And less than.
Less than. So I'm going to set up 2 statements, but they're separated with an and because less than.
But you just said an equal to 8, right?
No.
You do the less than. Okay.
Well, you do less than on the first one. Greater than negative 8. Let's see. And is usually the inside, and or is usually the outside. And is the overlap, or is sort of either or. So let's keep going here. 7n is less than 7. N is less than 1. And n is greater than negative 9/7.
They're open.
So negative 9/7 isn't great, but it's certainly smaller than positive 1, so it's not hard to find the number line. They are both open. Negative 9/7 and 1. Greater than negative 9/7, less than 1, but it's an and, so I want both things to be true. So that's the overlap region there.
Do we have to draw the arrows?
No, you don't have to draw the arrows. In fact, if you just can kind of figure out that it's the area between, then that's fine too. It didn't say give an interval notation. I wish it had. So let's add that to that. Answer an interval notation. So negative 9/7, comma 1. And that means any number between negative 9/7 and 1 will work back in my original inequality.
0 should and
Not including those two.
You're saying 0 should work.
0 should work. So you could check that. If I plug in 0, I get 9 plus 6 is 15. 9 times 1. 9 plus 6 is 15. 15 is definitely less than 78. So yeah, 0 works. And we did that on some. Like the other way to solve these is to like literally test an interval and see if it works or not. It's not really necessary on these.
That was just like the
Yes, yes.
Yeah.
I remember those. Those were so fun.
This is still a no, yes, no situation.
You could always just check 0 and find out the answer.
You can.
As long as you know.
You can always check 0 unless 0 is one of your solutions. You think we should do 8?
Yeah.
Let's do 8. Yeah, everything is negative, so lovely. Let's see, add 9 to both sides, I get negative 26, I think. Sure. Yeah, whatever.
Greater than or equal to 13.
Where did the greater than come from? Why are we? We divide by negative. We got to flip the inequality around.
What do you think negative 15?
Yeah, just 13.
Yeah.
Okay, so how am I going to split this one up? Greater than 13. Great. Negative 4x minus 5 is less than or equal to negative 13. And it's an or, so we're sort of expecting the greater amount of solutions. And yeah, we will have a sign switch again. Negative 4x greater than or equal to 18. X less than or equal to negative 9 halves. Or negative 4x less than or equal to negative 8. So x greater than or equal to 2. Man, all those negatives, lots of switching around in there. So you're pretty sure that's going to be a greater amount of solutions. And it is. Again, fractions, but no big deal. So, interval notation. Oh, a little bit weird with interval notation. Negative infinity to negative 9 halves. Union with 2 to infinity. Nine, 10, 11, 12. Why don't you pick one to do, and then I'll do it after you try it. Any thoughts? 9. All right, try 9. It's got some negative stuff in there. So you try number 9, and then I'll do it up here. Absolute value is less than negative. When is an absolute value less than a negative number? That doesn't make sense. So yeah, this is no solution. Again, be super careful. If you just keep working this using the process, you should still get no solution, but it's a whole lot easier if you recognize what's going on. Number 12.
Because if you graph it and stuff, you can get an and problem.
Let's go ahead and think that through. Less than is an and problem. If you graph it, you're going to end up with arrows pointing away. But you're looking for the overlap, and there isn't any overlap, so there's no solution. So you can still get there, kind of going the long way. Back to number 12. So we add 4 to both sides. I see a negative coming in our future here. 3 plus 4m is greater than negative 5, because we switched the inequality when we divided by negative 9. So when is an absolute value
Always greater.
Greater than negative, always. All numbers, or all real numbers.
Can't you do a weird R looking thing?
Yep. It's like a fancy R with an extra, whatever that's called. I wonder if that thing has a name. I don't know. If you did continue to work this one, so gray tor, it's an OR problem, but they would be overlapping. And when you want them, when anything shaded is part of your answer, well, then you'd have everything shaded and you'd have all real numbers. Hopefully it doesn't get to that. Hopefully you catch it right here.
So even if you figured out like the solutions, those would work too, right? The solutions, because it's
Yes, because if everything is shaded, because you're okay with anything shaded as part of the answer. And again, on a multiple choice test, when you see that as an answer choice, that kind of triggers your brain of, wait a minute, I better be thinking about what's going on here. Number 13, describe the transformations, then graph the function. We haven't done any popsicle sticks today, so let's pick on some people just to end the day on a good note, right? I think I see 3 different transformations that have gone on here. So Carson, tell me one thing that's happened to the parent function.
It's up 5.
It is up 5. Aaliyah, what else has happened to the parent function? It is flipped. And Preston, what else? Right 2. Right 2 up 5. There's my new starting point. Oh, before I even think about starting points, I should probably think about, Kennedy, what does this graph look like? Forget the transformations. Like, what's the parent function look like? It's the V. So the parent function would be a right side up V. It's flipped, so it'll be an upside down V. Okay. Right 2, up 5, and flipped. I mean, maybe this seems silly, but occasionally students get all the transformations right, but then graph the wrong function. Like graph a parabola or graph a square root.
It's always 1, 1.
It's always 1, 1. What would make it not 1, 1?
I feel like it's just like the parent function is 1, 1.
The parent function is 1, 1. That's right. If there was a multiplier out front that made the stretch, then you'd multiply the y values and you'd have a different slope. Last one. So kind of a backwards problem. So I think I see 3 transformations to this one. Luciana, how about what's one of the things that's happened to our original parabola here? Right 3. Cash, what else has happened? It's flipped. And Rena, what else? Up 2.
We don't have to put that in the equation.
Yeah, it says right.
Write the equation that could be used to describe g of x shown below. So g of x. Oh man, I can call on 3 more people. So Liam, how do I accomplish a right 3 in the formula or in an equation?
-5.
Well, I want
-3.
right 3 would be x minus 3. Alex, how do I make my graph flip? What? A negative. And Jackson, how do I make it go up 2?
+2.
And then there's a favorite wrong answer right there.
You gotta put square.
Right now it's not a parent function of a parabola, so I need that squared on there to make it a parabola. Okay, so there's the plan moving forward on how to split this thing up. Not that you need it, but well, that's off now because of the benchmark. We'll do the benchmark Monday, maybe. I don't even know yet. So, again, just a few at a time. I'll do some, leave some for you. And hopefully that way you'll get ready most of the time in class and not have a whole lot of homework